Okay, so hello dears, what's up? So good day, good evening, good afternoon ba, good morning. Okay, all right. Here we are again for another pre-recorded lecture in your analysis of urine and body fluids na laboratory. And this time, nibalik ta sa loom. O naman. Ano lang ta, balik lang sa loom karon. Because again, this topic is quite short. Dili ra kay kailangan og daghang board work or daghang mga side notes in a way. So, ginagmay lang. For this topic, we will discuss the quantitative estimation of urine total solids. Okay, all right. So, we have already discussed the microscopic exam of urine. So you already know what could be the cells or the different urinary elements that can be found in a urinary sediment or urine sediment, diba? So this time, what we'll do or what we need to accomplish is to quantitate them. So we want to count how many of the cells are there present in a urine sediment. Okay, so again, quite a short presentation lang. Munang galum ta, alright? Para po, di sa akong mapakitag face kay basi nalato naman sa akong face or para po, magpa-miss ako ninyo. Charot lang. Okay, anyway. Alright, so again, this is quantitative estimation of urine total solids. Okay, alright. So again, for urine total solids, the average total solids found in a 24-hour urine is about 60 grams. And the 60 grams is divided pa good into two types. So, 35 grams good are your organic components. So as you can see, mas daghan good ang organic. And the primary organic constituents pag yun na na-added to tulo ka buok is of course your urea, uric acid, and creatinine. Again, what is considered to be the primary organic component of urine? That is your of course, urea. Wag na mag-isip. Okay, and uric acid again, the product or of purine. Purine metabolism, uric acid, creatinine breakdown of muscle metabolism. Okay, all right. So creatinine. Okay, and of course, what is the primary inorganic component sa urine? You have chloride. Okay, wag na mag-isip. So dapat guys as early as now dapat karon memorize na ha, dapat dili na wala na yung mga loading, mga buffering when that is asked. Okay, all right. And of course, the remaining 25 grams is the inorganic part. As you can see, medyo gamay lang inorganic. So, ito na mga ions, you have chloride, potassium, mga sodium, mga nana. Okay, all right. So, as you can see, mas daghan good ang organic. All right, okay. Now, many attempts have been made in the past, especially kato itong mga scientists before, mga forefathers, kato mga bright yun, mga geniuses, they have already made attempts on correlating SG and estimation of total solids from SG. Because again, recall that your SG, specific gravity, is in a way determining the concentration of a urine specimen, diba? Or we know or we will know like in a way unsay mga um, how concentrated a specimen is based on the SG. Diba? Because again, SG is affected by the number of particles present and the size pagyud of the particles na naa. So in a way, it would be understandable that these no, dito mag ano gender gender stereotyping. These scientists focused or tried to their best to find a correlation between SG and the estimation of total solids. Okay, all right. Now, these presuppose kato ng mga attempts na again each of the solids has the same effect. Either ba they were thinking na kani ba ng mga solids they have the same effect kung different concentration of ihi or are the solids in a way affected by the concentration sa ihi or are they the same? Okay? Or the composition of urine ba is always the same in ana. So in a way muna lahang kanang driving force or driving thought as to why they were finding methods to quantitate total solids, di ba? So again, na by effect ang yeah, if they want to determine by if the total solids has the same effect per unit concentration sa ihi, if na by mga changes, or that ang urine composition is always the same in ana. Okay? All right. Now, we now go to different types of people, kato mga naningkamot, all right, or those who tried to really search or really examine this. So we have Long and Albaran. They pointed out na naay mga markedly changes or effects on SG of equal concentrations of the principal constituents of urine. So example, what it means, um, example, bahalag equal concentration of the urine constituents. Example, equal concentrations of RBCs na naa sa ihi, equal concentrations of WBCs, casts ba in ana. There are markedly effects or na mga marked effects ana sa SG, okay? Or na mga different effects sa SG. That's according to Long and Albaran. And according to Blom, Addis, and Foster, dili dili kaka derive daw og precise quantitative significance. Bahalag unsa na method mo gamiton sa pag-estimate of total solids from the SG because variable jud daw ang composition sa ihi. Alright? Okay, so muna ilang na conclusion or na conclude. You cannot find a precise quantitative significance. Bahalag unsa na method imong gamiton uh, to estimate solids from or by from SG or from specific gravity because again of the variable composition na naa sa ihi. So muna lang mga na-find out. Okay. All right. So sir, gano man tang kailangan Japon mo study ang mga methods? Okay. So we'll discuss that in the next few slides. Now again, we'll now talk about the different common methods in quantitating or estimating your urine total solids. So we'll have three. You have first is your Addis count, which is quite really popular and common. And the last two are your Hauser's and Long's coefficient method. Now, I have to emphasize, guys, that these methods, again, are quite or are obsolete. They are not really routinely used now in the laboratory. Like personally ako sa akong internship, I cannot recall bisag asa na hospital na nag-a-discount me sa CM na section. So, yeah, that would really support the notion na these are all obsolete. Okay, so wala na kayo sila ginagamit. Okay, but why do we still talk about them? Because again, it's important to know about these procedures. However obsolete, they in a way provide or paved the way for other important methods that we use now na ma-establish. Okay, so kailangan dyan na to we go back to our history, we should know our history, diba? Marcos never again. Joke lang. Okay. Never a hero. Yes naman. Okay, all right. So, again, these are the methods that we are going to discuss. Quite a short lang pod. Okay? All right. So, we'll start first with the Addis count. This Addis count procedure was discovered in 1926 by, of course, Thomas Addis. He developed the first method to to standardize quantitation of total solids or formed elements na makitaan sa microscopic analysis. Now, ang Addis count, we use a hemocytometer or a hemacytometer. Yes naman. So, confident na ko na, you have that in your HEMA 1. So, medyo familiar na with your hemocytometer, no? Yeah, I hate that. Joke lang. Again, yeah, nana mo ana. So, again, di na kayo foreign in yung hemocytometer. And for Addis count, what we look after is these four elements. You have your RBCs, WBCs, casts, and epithelial cells present in a 12-hour urine specimen. So 12-hour urine specimen or pwede po 24-hour urine specimen. Basta timed specimen, okay? So why do we use a timed specimen? Because again, in a way, timed specimen, you are collecting ihi over long periods of time. So in a way, makita dyan mo ang mga ihi na present at those particular time and in a way, makoncentrate po ang mga cells na present dito, okay? Or mga urinary elements na makitaan. In a way po, pwede nimo makitaan ng mga other cellular elements na wala nimo nakitaan if random lang ang ihi, okay? So this is quite important yun because again, this is quite important, especially if the patient is undergoing a pathological condition of renal origin. Because again, makita nato ang mga cells yun na present. Okay, all throughout the day or all throughout this long period of collection. Okay, so in a way, makagauge ta sa severity of the kidney disease and in a way po maka-predict ta sa prognosis or maka-monitor ta, okay, sa progression of the kidney disease. And that is why, yes, the primary reason why Addis count was created. It was created to monitor again the course of diagnosed cases of renal disease because again, makita naman nato, 'di ba nakita nato sa atong microscopic exam, each of your urinary element, may it be a cell, a cast, or a crystal, etc. They have their own clinical significance, 'di ba? So in a way sa atong pag-discount, atong pag-quantitate, makita nato if unsa na ba jud ka grabe ang disease na kidney disease sa patient, like naayo ba siya, nagka-okay ba iyang prognosis meaning nagka-okay ba iyang condition, maayo na ba siya inana or nagka-worsen. Okay, so muna siya point ana. But then however, again, this procedure is quite obsolete. It's now replaced by more sophisticated automated methods right now. And these automated methods, they do not require na timed ang specimens, pwede lang non-timed. And in a way, mas accurate pag yun siya. Mas reliable in a way ang result. Because again, kanina mga procedures, they are manual. So, pwede na yung mga variations sa technique sa medtech naga-perform, sa pagbasa pag yun sa medtech. So, in a way, mas okay itong automated, mas na-accurate na siya. Okay? Alright. So, that's why in a way, one of the reasons po nga na obsolete na sila ng mga methods. Alright? So, again, that's for Addis count. Now, For a discount, what are the materials that we need? Again, you have graduated cylinder, your WBC thoma pipette, you have the HEMA cytometer, cover slip sa HEMA cytometer, test tube, 10 ml, test tube rack, and disposable plastic pipette. Now, sir, nga mo gamit og WBC thoma pipette? Because again, your WBC thoma pipette has a bigger bore, na siya mas dakong buslot, ay, yes, compared to RBC thoma pipette. So therefore, it would facilitate the easier aspiration or the easier aspiration of the larger elements, especially mga casts or epithelial cells, di ba? So at least ma-appeal gud sila if we use the WBC thoma pipette kay mas dako yang bore kaysa the RBC thoma pipette. Okay. All right. And again, we have the calibrated conical tube because we use this for centrifugation because we want only the sediment yun, di ba? After centrifugation sa atong ihi, makita tong sediment, mo tong i-examine. And again, wala man tayo conical tube. I can't recall the conical tube sa CM before, so the normal test tube will suffice. Okay na to siya. And of course, centrifuge for centrifugation and microscope. Okay, all right. Now we go now to the precautions. Number one, the patient is restricted from all fluids. Usual diet lang but limit to 200 ml because again, we don't want na in a way ma-dilute ang atong mga cells na naa, which would uh, subject our procedure to inaccuracy in a way or gamay na ng mga cells at makitaan. All right. Number two, low pH lang, at least pH 6 or lower because in alkaline urine, pwede nang mo-disintegrate ato mga cells, di ba? Kaya remember mo, di ba, if prolonged standing of urine without proper preservation, like refrigeration ba or anything, mo disintegrate ato mga cells and casts. And of course, over time, your urine pH becomes alkaline. So, mo deteriorate mo disintegrate na yung mga urinary elements. So, wala na pulos atong pag-discount or pag-quantitate. Okay? All right. And room temperature Japon, samot na na ref because again, di ba, mo precipitate ato mga amorphous materials, mga urates. So, which could again be difficult or which would make the examination or quantitation difficult for us. So we don't want that to happen. So dapat room temperature good siya, samot na if na ref ang imuhang specimen. Okay, and specific gravity should be at least 1.022. Now, I don't know the specific reason why kailangan ni siyang inani, but I think less than 1.022 man good guys. So medyo dili kayo concentrated ang specimen. So in a way wala kayo tayo makita ng mga cells. All right? Or dili kayo effective na in a way atong pag-quantitate. So ang iyang spec grav is at least 1.022. Okay, all right. Ayan. Okay, now we go now to the procedure. Number one is, of course, since this is a 12-hour or 24-hour urine specimen, timed urine specimen, we always have to measure the total urine volume, of course. Muna pulo sa graduated cylinder. Okay, so ato na i-measure dito. And then really sadya yun yung mga inani guys. Samot na, you'll have a 24-hour urine specimen na po din clean chem ninyo na lab sa creatinine clearance. And if na-perform niyo siya in real life sa lab yun, ako personally, akong gigamit sa una kay katong 6 liters na absolute. Ina nakadagan akong ihi, yes. Kay 24-hour urine specimen to siya. So sadya ang pag-collect. And you have to measure all good. So mabot to mga 700 ml, mga nana, di ba? Yeah, mga nana or mga 1 liter jud ang ihi. So yeah, sadya siya. Okay, so again, first procedure, measure the total urine volume. Next, we only need 10 ml sa labeled tube, okay? And then we subject it to centrifugation for 5 minutes at the normal na settings, of course, at 115 to 2000 RPM. Of course, decant the supernatant, di ba? Bottoms up, na mabili na lang is 0.5 to 1 ml na sediment volume to be examined. And then aspirate using the WBC thoma pipette. Wala na tayo gamito ng mga reagents di para sa inyong hima. Alright, so wala ray reagents. Aspirate diretso sa WBC thoma pipette. Charge sa hima cytometer. Oh my God, as in like, charging sa hima cytometer is one of the mga skills or mga tests na makatest sa imong patients po. Kaya like stressful kayo siya, di ba? Kaya dapat dili siya manglapaw, dili siya mo ano, dapat perfect yun siya at one charge lang. So hassle. Okay, anyway, all right. So again, charge the HEMA cytometer. Next, we count the sediments. Diba, in your chamber, you have 9 large squares. And we count all the sediments that can be found in the 9 large squares. So again, 4 rakas sediments atong or 4 rakas cells atong gina-examine. You have casts, RBCs, WBCs, and epithelial cells. Now, ngano kanirang upat? Because again, these 4 are quite very much indicative na gyud of renal disease. Okay? Because again, di ba, mga casts, samot na kay casts, gikan gyud sa kidneys, RBCs, WBCs, bleeding or infection, and epithelial cells, example, if kag mga RTEs, so gikan gyud sa kidneys. So again, munang in a way, naka-focus ani na four ka cells because again, they are quite indicative na gyud og renal damage. Okay? All right. So what we do is again, start sa tag usa ka sediment or usa ka element, example casts under LPO. So from the first large square until the ninth large square atong i-count tanan. Count nato tanang casts na makitaan. Okay, after na pod casts, proceed to HPO, RBCs, okay, next na po WBCs, and then epithelial cells. Ang epithelial cells depende sa type of epithelial cells na imong lantawon. Of course, if mga RTEs and transitional epithelial cells, sa HPO ka, okay, because again, these are quite small na mga epithelial cells. But if dito ka sa mga squamous, if squamous imong ginalantaw or imong ginalook after, then of course, dito rata sa LPO because again, these are big squamous epithelial cells. All right? Okay, so muna siya yung procedure for a discount. Now, we report again using the formula for each sediment type. So meaning for the casts, ato i-calculate using this formula. For RBCs, calculate po taan eh. For WBCs, etc. Okay? All right. So this is the formula. Again, where the capital N is the number of cells ba or casts per 12 hours or 24 hours. Small n is the average. So average number of casts or cells ba na atong nakitaan sa 9 large squares. Okay? Capital S is the volume of the mixed sediment, meaning katong sediment na atong i-examine, di ba? That's 0.5 to 1 ml. So we usually put that as 1 ml unless gi-specify gyud siya na zero point 0.5 ra, zero point 0.6. Okay? Alright. Small v is the volume natong gikuha from the total volume sa ihi, di ba? That's only 10 ml. I joke, sorry. Volume where the count is made pala, sorry. That's equivalent to 0.0009 ml. That's constant, okay? Capital V is the total volume of your urine per 24 hours or 12 hours. And 10, of course, the volume of aliquot natong gigamit, di ba? From the total volume of ihi ni kuara kag 10 ml to be centrifuged, okay? All right, so muna siya ang ato ang components atong formula. So please take note. Again, each type of cell, okay, ato na siyang or for each sediment type, ato na siyang gamiton ani na formula. So for cast, kanina formula. For RBCs, kani pod ato i-count, and WBCs, etc. All right. And these are your normal, okay, before we proceed to the normal sana results, okay? Nganong 0.0009 ml, di ba? Katong letter, uh, small v. Okay, di ba? Remember, we used the Neubauer chamber. And again, the large square, di ba, ang whole chamber yun, 3 millimeter ang iyahang length. Okay, all right. And each square, 1 millimeter iyahang sides. And we use, again, 9 kabuok. All right, so 9 kabuok na large squares. Therefore, the total area that we use is 9 millimeter squared. And again, remember, the depth is always 0.1 millimeter. Okay, now, for the volume, we calculate the volume by multiplying the area and depth, and we will arrive at 0.9 millimeter cube. Now, we need ml man. So we convert millimeter cube to ml. Now, please take note, 1 ml is equal to 1 cm cube. Diba? cc, cubic centimeter, or cm cube, that's equivalent yun to ml. Okay, 1 ml. Now, what we need is millimeter cube man. So, therefore, ang 1 cm is equal to 10 millimeter. So, we multiply 10 millimeter 3 times by itself para makaabot ta og millimeter cube. So, therefore, 1 ml is equal to 1,000 millimeter cube. Now, using this conversion factor, we use 0.9 millimeter cube. All right? And then, cancel millimeter cube para mawala millimeter cube. So therefore, para you will arrive at ml. Hence, ang result is 0.0009 ml. Okay? All right. I hope this is quite clear lang. Why we use 0.0009 ml. Okay? All right. Because again, we count the 9 large squares. Area counted nimo total is 9 millimeter squared. Volume therefore nimo is 9 millimeter squared times 0.1 millimeter. You have 0.9 millimeter cube. But then you need ml man. So you convert millimeter cube to ml. Hence 0.0009 ml. Okay? All right. Now here again your normal values. RBC 0 to 500,000. White blood cells, epithelial cells, same 0 to 1.8 million. And then hyaline casts 0 to 5,000. Now as you can see, ang mga casts or hyaline, gagmay ra gyud usually yung values because again, they're not quite commonly seen in urinary sediment na kanang normal. Okay? Normal urine sediment. Diba? Hyaline casts quite a few ra gyud mo makitaan. Okay, all right. So again, these are your normal values. Okay. Now we now go to your other methods. Now the remaining two methods are quite the same lang. All right. Na differ lang sila. There's just a small difference of formula. Okay. All right. So still the same 24-hour urine specimen. If refrigerated, allow it to cool down at room temperature. Still the same reason we don't want the amorphous urates to precipitate. Okay, because again these can hamper or can hinder our examination and quantitation. Okay, again, mix entire sample, still the same because again, para kato mga settle na elements sa ubos, maapil. And then we determine now the SG using a reagent strip and we compute for the total solids. Now, you can see guys ang difference sa addis count and the last two methods. Ang last two methods mga good, we don't need to specify or we don't need to count each specific na mga urinary sediment like parehas sa addis count now. We count for CAS, we count for RBCs, we count for WBCs. For Hauser's and Long's coefficient, we account na gyud for the total solids like tanang solids na makitan sa ihi regardless of the cell type na naa didto. So regardless if naba na crystals, naba na siya cast, naba na siya other cells, basta the or the result of this is the total solids na gyud na naa sa ihi regardless of the type of cell or sediment na makitaan dito. Okay? All right. So again, this is the formula. You have last two digits of SG times a factor, which is a constant, and urine volume, ml per 24 hours, over 1,000 ml or 1 liter. So 1,000 ml. So that's the standard that they tested when they were creating this formula. Okay, and again, ang difference lang is for the factors. Ang Hausers mo gamit yung 2.33 and ang Longs kay 2.6. Now, unsa akong pag-remember, ana, ang long sky, long man siya, di ba? So medyo high or long, medyo taas. So therefore, ihang factor is mas taas. So 2.6. And then of course, kinsa na 2.33 ang Hausers. Okay, Hausers. Or na may owning yung mnemonic, ikaw na bahala na. So again, ang difference nila is ang factor 2.33, 2.6 ang Long's coefficient method. Now, recall di ba sa mga second slide ganina, niingon na to si Addis, silang Foster ug si Blom na walay significance ang pag-estimate og solids from the SG. Now, you may be asking, sir, ganong ang Hausers og Longs kay mo gamit og SG? Kana, wala na inform sila. Di sila friends atong time. So, wala sila na-inform. Competition to sila. Joke ra. Actually, I don't know the exact reason as to why po nga, no. Because again, if I search about this or I read about this, wala kayo sila gina-discuss. Because again, they're quite obsolete methods. But I think, I think personally, akong pagsabot, why they use the SG is because um, maybe it's a part of their method. It was their way of testing. It was included in their way of really trying to prove, 'di ba, na the SG can be used in a way para ma-estimate ang mga total solids. Okay? So again, I'm not dili ni siya ka na establish guna reason. I think this is just my own deduction from this. They were munilahang na derived na method, derived na way to really prove their claim siguro or to really support the notion na pwedeng ma-calculate or ma-estimate ang solids by using the SG of the urine specimen. Okay, but again, according to nilang Addis, 'di ba, etc., et al., dili walay pulos daw. Okay, all right. But again, these methods are still established. Bahala ana si Hausers and si Longs. So again, but again, um, in general or in conclusion, these methods are obsolete. So we don't use them routinely na karon sa lab. We opt na for if we really need to quantitate, usually mag-automated methods na ta. But again, so why do we still study this? Because again, these methods are really significant. They are important because again, bahalag obsolete na sila. In a way, they are part of history sa pag-examine sa ihi. They pave the way again to methods ron that are much more advanced. These methods in a way pod ang gibasihan or gikuhaan og inspiration from, di ba? Sa mga methods karon. So of course, we need to revisit our history pod naman. Char naman. Yes naman. Okay. So that's the end of our presentation on this topic. Again, quite short, di ba? So, munang galum lang sa takaron. Para naman po voice lang, akong beautiful voice. Inyong madunggan. Yes naman, Char. Okay, so again, that's all for quantitation of total solids. Again, I hope that's quite clear lang. Just take note, the main purpose lang yun, or like the main significance as to why we are performing this test is we just want to monitor, okay? Monitor the progression of diagnose renal diseases. Okay, not more of diagnosing, because again, these methods are manual procedures, so na mga variations on techniques by different medtechs or different examiners. But again, the point lang yun is we just want to monitor, okay, the progression of kidney disease, renal disease by quantitating and examining the presence of particular urine sediments, example sa Addis count, di ba? RBCs, WBCs, CAS, and epithelial cells, and total urine solids, regardless of the type of the cells na present sa specimen in your Hauser's and Long's coefficient method. Okay, so again, that's all for this topic, dears. I do hope to see you in our next topic soon in our pre-recorded lecture. So have a great day and keep safe.